Welcome to Group 5's presentation for SETK 3413 Pollution Control. Our theme today is Clear Waters 2025, Protect Our Waters, Secure Our Future. We often take the water from our taps for granted, but the reality is that our water security depends on a very fragile network of waters. Today I'll start as the first presenter for our group. I'm Xue Ting. So let's look at this map. This is the lifeblood of our region. It starts at Sungai Kabul, flowing into Sungai Beranang and then Sungai Semene, eventually feeding the Sungai Semene water treatment plant. This plant is critical as it serves over 1 million residents in Selangor and Putrajaya. However, the 2025 reality is alarming. Small tributaries like Sungai Kabul are often unseen hotspots where illegal industrial discharges can go unnoticed until it's almost too late. Now, let's look at a chilling example of this incident. On January 14, 2025 at 6:40 p.m., a routine Luas patrol had discovered something terrifying. The water has turned a vibrant synthetic pink. The authorities didn't hesitate. By January 15, a yellow alert was activated under the Water Resources Pollution Emergency Manual. This wasn't just a small spill, the pink effluent stretched over 500 meters along the river. The investigation traced the source to a factory in Beranang industrial area. It was an illegal discharge from the final point of a facility that had failed to protect our raw water source. This incident forced an immediate halt to factory operations and a massive cleanup directive under the Luas Enactment 1999. The evidence was undeniable. As you can see in these pictures, the river looked more like a chemical dump than a natural water source. Analysis showed the presence of synthetic dyes and dangerous heavy metals like lead, mercury, and cadmium. Let's look at the numbers that define this crisis. The pollution was detected 16.3 kilometers away from the water intake. While 60 kilometers might seem far, water travels fast. If that plume had reached the intake, it would have been a catastrophe. The threshold odor number TON was recorded at 2, making the water completely unsafe for treatment. This is a near miss. If Luas hadn't triggered that code yellow just in time, this dye would have entered the plant and permanently destroyed the expensive filtration media of the Semene water treatment plant. This case study proves that our future depends on early detection and rapid response. Now, my teammate will explain the technical chemistry behind these specific contaminants.
So hi, I'm Ryu, and I will present the science behind this pollution. We have seen the Pink River before, but my job is to tell you what exactly inside the water and why it is so dangerous. First, look at the chemicals. Based on our research, this wasn't just food coloring. It was a toxic cocktail of 3 deadly things. First is the color. This comes from synthetic azo-dyes used in textile printing. They are the reason the river turned the pink color. Second is the poison. We found heavy metals like lead and cadmium. They are invisible, but they are killers. They don't disappear. They stay in the water forever and damage human organs. Third is the smell. The sharp chemical odor came from organic solvents. These are highly toxic and can cause cancer. When this toxic mix flows down the river, it starts a deadly chain reaction. First, the human impact. The dyes are carcinogenic, which means they are linked to cancer. Even worse, heavy metals enter the food chain. The fish eat the contaminated particles, and when we eat the fish, the poison enters us. Second is the ecological impact. The river basically suffocates. The pink dye forms a shield on the surface that blocks sunlight. Without light, aquatic plants die, and the oxygen levels drop, and the fish suffocate. So here is an easy diagram to help you for better understand. As you can see, it's a complete cycle of toxicity. Now, the big question is, why our treatment plant cannot just filter this out? The answer is in the chemistry. Look at this molecule on the screen. This red circle shows a double nitrogen bond. It is chemically engineered to be indestructible, so that color doesn't fade your clothes from the washing machine. But that same strength makes it impossible for natural bacteria to break it down. Also, these dyes are water-loving. They dissolve perfectly in the water, which allows them to slip right through our standard sense filter. That's why, when this chemical hit the intake, we have no choice but to shut the entire plant down.
Name is Joanne, and I will talk about the water treatment plant's intake gate. So most water treatment plants in Malaysia are optimized for class 2 river water, focusing on natural organic matter, turbidity, and also pathogens. They are not designed for the concentration shock of synthetic dyes. These industrial pollutants are resistant, chemically stable, and also highly resistant to biological oxidation. So when this pink effluent hits Sungai Kabul, the traditional sand filter will bypass by the low molecular wet dye molecules. To prevent this toxin from entering our household tap, the plants were forced into a total intake shutdown. So let's talk about the engineering impacts about the retention time. So a major disruption occurs within the retention time. So that molecules move via a retardation mechanism unlike the water. So they absorb onto the surface and the filter media, prolonging their presence in the system far beyond the standard residence time. Furthermore, the high COD from the waste requires significantly longer contact time for neutralization than existing design allow. For coagulation with aluminum sulfate or PAC to work, every pollutant molecule must collide with a coagulant ion. At this high concentration, the probability of escape pollutant increase, leading to incomplete and unsafe treatment. So next is about the filter clogging and also the media falling. Physically, the plants face media falling. Industrial surfactants and also dyes interfere with the electrical charge of particles, preventing the formation of heavy settable flocks. Instead, we get pin flocks that lock deep within the same filter pores. This causes rapid head loss, or steep pressure drops that force the plant into frequent backwashing cycles. This doesn't just reduce the water output, it causes massive operational strain, skyrocketing our energy and also chemical costs by millions. Next is about the human and eco impact. So the cost of the negligence is devastating. Ecologically, intense dye coloration blocks sunlight, halting photosynthesis, and creating hypoxic dead zone where aquatic life literally cannot breathe. For the public, dyes like rhodamine B and potential carcinogen that can cause acute organ damage to the liver or kidneys. Economically, a single major pollution event can cost our region up to 6% of its GDP due to industrial downtime and 100 million ringgit in government mandated cleanup efforts. Now I will talk about the ways to improve WTP design. The first, the riverbank filtration (RBF) as a pre-treatment buffer to catch heavy metal. The second one, dissolved air filtration (DAF) to float off the oil chemical residues. The third one is the upgrading to ultrafiltration UF membranes for 99.9 physical barriers. And then finally, the fourth one is the advanced oxidation AOP to chemically shatter recalcitrant dyes molecules. So only through this engineering advancement can we truly secure our future water supply.
Hi, my name is Marcus Valentine Chua, and I'm going to be presenting on solutions and preventive measures. So there are three solutions that I've provided. The first one being activated carbon absorption and bioaugmentation with ozonation. Okay, so the first one, activated carbon absorption. It uses activated carbon that acts as a molecular sponge that just traps dye physically, traps the color physically lah. And the second one, bioaugmentation, we uses a microorganism to let them eat the complex dye molecule. So these two actually make sure that the water is not pinkish in color already. And the third one is adding chemicals oxidants that attack chromophore and also breaks the color molecule. Okay, so now into the preventive measures. We have two technology which are Hydra Station and Digital Twin. Hydra Station with its function being a real-time detection, and we can locate it on the along the river for it to detect the pH and turbidity spikes. And these two are the things that can be detected if the dye are being poured unprocessed into the river. And for digital twin ICC, it is actually a complete model of the river flow. And using it, we can be able to identify the river flow, and then we can stop the contamination spread from early stages. On to the call to action. We need to know what we can do as civilians. We need to report, protect, and secure. If we see something wrong, we report it. If we suspect something, we record and we report it. And here is what we are trying to secure, the beauty of nature. We need to understand that clean water is not a luxury, it is a right. But keeping it clean is a shared responsibility. So, together, let's report, protect, and secure our future.